throughout the webinar, but I don't trust my internet this evening because we had quite a rainy day. So sometimes I might just have to put up my video to improve the bandwidth. So I'm happy to be here once again. And without any further ado, I'm going to share the slide. So you can see my screen quite well, right? Is this okay?
Yes, ma'am.
Yes, ma'am. Yes.
Okay.
Yes,
All
ma'am.
right. So while I'm presenting, I'm just gonna put up my video just so that it helps the internet a little bit. And afterwards, when we're having the discussion session, and back. So once again, thank you so much for inviting me here. This is what I love to do best, just talking about science, talking about what I do, and just enlightening people and improving and increasing knowledge about what space physics, space science is really about. So yeah, as it has been said earlier, my name is Dorcas Seni. I completed my bachelor's from FUTA. I studied physics with electronics, and I was fortunate enough to have my research in atmospheric physics, and I think that was what began to get me closer to the space, but not close enough, right? And I went ahead to have my master's at AP Brazil, where I did space geophysics, and I'm actually done now, so not I'm not a current master's student anymore. And my research was on solar physics, the sun, or heliophysics, or we could say space weather too. So we'll get to see that a little bit today. And hobbies, I think I just like teaching. I love educating. I love it so much. I love music and just doing anything creative. Yeah. So yeah. So I said I started with physics, and this is sort of like a summary map of what physics is about, but really beyond this. Um, but before I continue, I just want to, if we can quickly drop in the chat what our background is, just so I want to have an idea of what the audience is. You can quickly drop in the chat, maybe if you're a student, what you're currently studying, or if you've graduated, what you've studied, what you studied, just to have an idea. Can we quickly do that? Biochemistry, okay. Biochemistry too. Okay, we've only had 2 responses. So biotechnology, okay, so it's majorly biology, chemistry, and the rest. Biochemistry again, okay. So 4 answers so far, biotechnology. So okay, now that's good. So you're from more of the life science aspect. So that's good. Crop science and personal. Thank you so much for the responses. So I wouldn't do too much physics today, just so I wouldn't bore you out. But then there are still some things that would be interesting to share. So yeah, so physics is really broad, and everything around us is basically governed by the law of physics. So we have the laws of motion, how cars move, for example. When you think about a solar turbine, when you think about a gyroscope, when you think about optics, light, when you think about how a telescope works, when you think about the waves of the ocean and a lot of things, application, we know that those are physics. And I mean, it was pretty fun studying physics, but was much more of stressful because I had to deal with so many theory, and I think it got overwhelming and eventually drove out the fun for me. And I think I remember towards the end of my bachelor's, I was wondering, what exactly do I want to do with this physics? I mean, I've learned so many equations, so many theory, so many so many laws, so many principles, and I couldn't still figure out what exactly I'm going to use this for. But well, science has so much to offer. That is the beautiful part. So I'm just going to highlight a little bit of physics that stood out for me. And so, for example, I remember when I was in 300 level, and I first come in contact with superconductors. I know we all know conductors and we all know insulators, right? And but this was given as a term paper, and the question was if you have a conductor and you're able to drop the temperature far below 0 degrees, what do you think you have? You have a superconductor, such that if you place the magnet on a superconductor, then it's levitating on it, it doesn't touch it. And this is an example of that here. And that is the technology behind the really fast trains we have today, levitating train. And then I remember the first time I learned about the concept of relativity, which is really interesting. And the concept is if you have two identical twins and one decides to travel to not a far galaxy now, just somewhere close in space, but now traveling close to the speed of light. And maybe after what she feels like, after what the identical twin feels like a short distance of time, decides to return back to Earth. What she finds out, in this case, is she, right? What she finds out is that the identical twin, the other twin she left on Earth, is already aged because the faster you travel, the slower time moves. So for her, because she's traveling at the speed close to the speed of light, which is 300 million kilometers per second. I forgot that for a moment. 300 million meter per second. So time moves slower for her, and she's younger. And holography too was fun for me. And yeah, not to dwell too much on this. And afterwards, which is what people would call the entertainment part of things, but it's interesting how they could also give insight into what building career in certain areas can look like for us. And the first entertainment like stuff to give me that feel was this movie, Hidden Figures. So Hidden Figures was based on three women in the early 90s when NASA during the space race, I'm sure we've all maybe heard or somehow heard there was a particular time when NASA and Russia were competing and see who would be the first person to send human to space, who would be the first person to send spacecraft to space, and so who would be the first person to touch the moon, and just they were just competing. I mean, blowing money anyways. So we had these three women which were really important to the first man American man specifically that was sent to space. And this was a motivational and a really turning point for me along the path of my physics career. And this is a scene in the movie where this lady, and this is the actual person she's acting. She's acting. Is that the word? I don't know. So, and her name is Katrin Johnson. She's a NASA mathematician. I think she passed away recently at about the age of 1900, thereabout. So, when she was calculating the trajectory that the spacecraft was going to travel using Euler's equation, and I did Euler's equation in 200 level. It didn't make sense to me, but seeing it live in the movie as used. Okay, so this is it where it was calculating the trajectory on how it was going to be launched from Earth, moving. So at this little curves we are seeing differential equations and how it's going to move and meet the moon, even though the moon is also moving on its own orbit around the Earth, but it's going to move exactly meet the moon, and then by the time it's leaving the moon, of course, wouldn't be at the same position as when the spacecraft met it. Then calculate the trajectory again from that point back to Earth, which is really crazy mathematics. But it was fun, and that was when I began to think, well, don't you think space science could be something I want to do? But then, of course, there's no surrounding resources to even ever think of that. So yeah, that just was at the back of my head. And so somehow, someday, and in 2019, I was just browsing on my phone, checking opportunities, anything to just keep me alive because service was a bit boring for me then. And I came came across a summer school for astronomy, and it was a Pan-African school. It's formerly YSEA, but it's now called PASIA, Pan-African School for Emerging Astronomers, where there'll be instructors from all over the world. And then they were taking the students in Nigeria, so it was done in Nigeria that in that particular year. Now it's being rotated in different African countries, and it was a great experience. And this is why one thing I always emphasize, that if you're looking into going to a field, and if we just limit ourselves to what we've been taught in school, then there is really no fun in it. But getting into the practical and really application part is what really help us experience and know why are we even doing this in the first place. And this was a great also turning point for me, where you we all know the Pythagoras theorem we used in secondary school, and now getting to use that. Oh, I forgot to include the picture here. Getting to use this Pythagoras theorem, for example, to calculate the distance between Earth and a constellation that is not so far from Earth. When I say not so far, I mean not so far compared to other stars, but it's still very far. So the constellation is a collection. This it's in the Bible. If you're Christian, you would have seen it in the Bible. Pleiades. It's also called seven sisters. It's also called the seven sisters because with the naked eye you can only see seven stars in that constellation, but it actually contains more than that. I'm able to use just simple mathematics to calculate the distance between Earth and that constellation, which was really cool for me. Really cool. And yeah, this was one of the pictures I was taking after the program, just for the women. There were also guys there, just to put that out there. And from there, I was able to leverage on this particular opportunity. I wrote this in capital letter, networking. That was a key thing. After all the length, the knowledge, got to know what astronomy is. I got to know finally at the age of 20 plus that the sun is actually a star. And but the key thing that took me out and set me up for the next for my career in space science was networking part, and that was having the courage, picking up and approaching one of the not one of the instructor, but one of the major figure that was part of the organizers, and just saying, I know your name, I've seen you, I've heard your name in footer, but I've never gotten to meet you before. I'm interested in continuing on this path, and the rest they say is history. And so yeah, so after getting all this, I just want to check to see if I'm not talking to myself. Can you all still hear me?
Yes, ma'am.
Okay, thank you so much. Okay, so from there was still the big question. Now I've learned astronomy, I've learned stars, it's very mind blowing, it's cool. What exactly am I going to do? The environment. And like, okay, what do I mean? Thank you for recent years in the space industry. So for some people, like a lot of you here, you have biology background, and for other people, you have okay, I'm still here. So and for other people, they have chemistry background, and with that, you've learned some laws, you've learned some principle, and I remember, okay, I did a bit of Fortran in Footer. I didn't do any Python, but well, Fortran was something. I learned some principles of mathematical modeling. I was able to do a complete research in my undergraduate. I'm like, that is something. I'm not just any random person. I've gained certain knowledge. So how can this help me to transition into what I want? And then the answer was just, I need to gain more knowledge. I need to gain more networks, and I need to get myself mentored. So yeah, there's a quote I'll you see later on about how mentorship is actually really important. So to gain knowledge, what could I do? And I decided the answer would be to pursue a graduate graduate studies in astronomy, space science. Yeah. So, but before that, the point is, space science is so broad that you don't even know exactly where to fit in, and that is it for many careers. Biology is so broad in itself. Sorry, someone is unmuted. Okay, yeah. So biology in itself is very broad. Chemistry itself is very broad. Physics itself is super broad. Space science itself is super broad. And then, what aspect do I really want to go into? And I began, and the first step I began to take was beginning to look for communities. Now, science coin. Sorry, I don't know how to pronounce this well. Science coin. Help me if I'm getting it wrong. It's a community on its own, and you guys are doing amazing things. And what that was one of the first major steps I began to take, beginning to connect myself to community of people of like-minded who are working in similar, who are working where I'm going to. So I'm not there yet, but there are people working there, and there are people that are also aspiring to get there. So then I find people on my level and people beyond my level. And one of those first one was Space Generation Advisory Council, which I recommend to anybody. I mean, anybody that is interested in space. Just check this out, and yeah. And then I came across Space in Africa, and I registered as an intern there. LinkedIn is a super amazing platform that really contributed to my career. Supernova Foundation was a mentoring program. I began to learn Python. Later on, which was recently, I joined Blue Marble Space Institute of Science, and I joined Women of Color Code, and now I'm also part of the African Network of Women in Astronomy. But yeah, this journey did not start immediately. There were so many things that led up to that, and I'll just like give a little bit insight into some of those my experiences. So the first official space assignment or space work I did I did after the summer school was I joined Space in Africa. So Space in Africa, they write news about Africa. In case you've heard, the founder is a Futarian too. The founder of Space in Africa is a Futarian, and they cover news in Africa. And they organize programs and yeah, just focus on putting the African space industry on the global map. That's really their mission, sort of. And I applied to be an intern from someone that had no experience in space whatsoever, but just passion. That was all, just passion. And I was accepted, and I started working, started attending workshops to cover news, started interviewing really top people in the space field. And networking was made easier because I was able to share my articles on LinkedIn and people were engaging with it. And I see people messaging me on LinkedIn just because I was working for Space in Africa. And I'm like, well, I don't know anything. I'm still new in this field, but well, thank you for thinking so highly of me. And it began to give me direct access to opportunity. But there's a but, and yeah, something I learned later on. I did not maximize the opportunity. So because it was an unpaid internship, I didn't stay long. I left after a year. And looking back, I saw so many opportunities I missed because I left too early. So maybe that could be a lesson for someone, but it's a lesson for me for sure that yeah, opportunities can come in disguise and not to just look down on them sometimes. And afterwards, I joined Space Generation Advisory Council. I began to participate in some hackathons. That was where I began to develop my coding. I said you need to gain knowledge, right? And I found out that to work in the space science field, you have to be good in programming languages. You have to know what you're doing. You have to be able to analyze it. And one of the easiest way for me is just get into the fun side and competitive side of it, which was hackathons, right? And I was able to participate in exciting projects. For example, we did a project where we wanted to send a spacecraft, a mission to Mercury, planet Mercury, to get a sample from Mercury and bring it back to Earth. And it was a really, really super fun project. And because my background was physics, I led the subsystem for the power. And, we got to participate in conferences as delegate from Nigeria. It was awesome. So SGAC has a lot of working groups. So they have a lot of working groups. They have the space exploration working group. They have the space law working group. They have the building satellite. I think for the space exploration project group, they have things related to astrobiology. They do some projects related to life outside the Earth. So if that's what interests you, and a lot of other things like that. So these were how I was building experience. And then mentorship. Supernova Foundation was a really huge stepping stone. I just put in this code like, if you cannot see where you're going, ask someone who has been there before. And coincidentally, I was paired with a mentor from Brazil, and I never knew then that I was gonna study in Brazil. But then it happened, and I've been there for that long, and now I'm part of the leadership committee, and I'm hoping to help others to also get mentored appropriately, which is an exciting experience. And recently, I just joined the Blue Marble Space Institute of Science, which is, some of these organizations are just structured such that you get network to the toppest people in your field just cheaply. Just because you're part of this organization, you can talk to anyone. You can talk to anyone. It's crazy, but it's interesting. And at Marble Space Institute of Science, I was able to. How cool is that? NASA is like top. Maybe because I didn't dream big enough that I would there. But now that seems like something that is more than possible now. And space education programs. And I got connected with more organizations related to my interests. And that's the good part with it. So for example, if I have a supervisor that's not directly in what I'm interested in, he or she can recommend me to other people, other organizations that I can leverage and give more visibility to even gain more. And that was it. Again, sense of community. If I publish a paper today, I just need to submit it to the community, and then it's published in their newsletter. And I don't know how many people read their newsletter, thousands of people, and your work is just given visibility just like that. And one of the major, a little bit setback for me was because it was astrobiology focused. And kudos to you guys doing biology and chemistry. They were like, I wouldn't say nightmare, but they were tough for me to chill back then in secondary school. I love the life aspect of science, but having to do the rigorous biology study was hectic for me. So, but which is cool. The institute is majorly astrobiology focused, and every now and then, I think every month they do webinars. I think if you just check Ask an Astrobiologist on YouTube, you see there's a webinar series that they do every month where they feature some astrobiologists from across the world and things like that. So if it's something you're interested in, I will highly recommend it. There are different routes through which you can get through to the program as a visiting scholar or as a young scholar, YSP, Young Scholars Program, something like that. So if you're an undergraduate, you have to go through the Young Scholars Program. But if you're a graduate, you have to go through the Visiting Scholars Program. Yeah. So you can, through it, you can just, if you have something that just interests you that you want to work on, but you don't have to go about it, you just want a supervisor and a mentor. That's all. That's the criteria. That's all. So yeah, that's it. So from there, gaining experience from this thing now sort of paved my path towards having my master's in Brazil. And here is the front of my school, National Institute for Space Research in Brazil. Yeah, the courses they do: astrophysics, space engineering and technology, space physics, remote sensing, meteorology, applied computing, and earth system science. So in Brazil, I wouldn't say it's quite easier to get into their program, but the major part is you just have to write an exam and you have to pass it. Once you pass the exam, if it's in an institute like this institute I finished from, then you don't have to bother about funding. But if it's for normal universities in Brazil, then you have to still apply or try to source for funding separately. And yeah, averagely in Brazil, their their programs are tuition free. So of course you need funding to then support your normal day-to-day living, and that's it. So yeah, I started in Impi in Brazil, and one of the first thing that caught my attention was this guy here, this glowing thing. And you know, we've been seeing the sun ever since we were born, but I never expected what I was hearing. How dynamic, how how energetic the sun can be. It was cool, and I'm like, okay, this is what I want to do. And I'll just play a short video here. And one of those most energetic things that happens on the sun. Sorry. Let's see if I can get this to play. Should play by itself. Okay. So here's an example. So this is called a coronal mass ejection, which is a very powerful ejection. I think it's one of the most energetic eruptions from the sun. And here the video is being taken of the sun using a coronagraph. So the coronagraph has a black disc that covers the sun and its brightness so that we can see the surroundings, so that we can see the atmosphere of the sun. And that's when we can clearly see those crazy things that are coming out of the sun. And these things goes in all direction. So if they're going in all direction, that means they can come towards Earth, right? So what could happen if they come towards Earth? So the big picture is using the word space weather. So we all know weather here on Earth, that atmospheric condition changes and stuff like that. So now, what does weather look like in space? So for example, talking about this eruption we just saw now. So it can cause a lot of things in space, and it can also cause a lot of things on Earth. And this is just a little bit out of the things it can cause. So for example, well, everybody wants to travel to space now, maybe to mine, to get samples, to look for life. There's life outside there, to just understand how things work. When humans are outside the Earth's atmosphere, because the atmosphere is like a shield to us, right? They get more susceptible to getting affected by this eruption. So that's dangerous. Our satellites in space can be destroyed. I mean, completely fried by these ejections. It could even affect airplanes right here on Earth. So